So now we can move on to division or dividing integers. Well, first off, just like multiplication, division has its unique symbols. So, going to put the most common, which is this division sign. But there's another one that can be used, and it looks like a / on your computer. A good way to remember this is just a guy leaning forward here. And a variation of this / is a division bar, which you have typically a number on top and a number on bottom. What I'm going to do is put some variables on top of both of these. I'll just put an x here that can be represented with any number, and a y here that can be represented with any number other than 0. 0 cannot go in the denominator. And the same here, I'd put an x down, our / followed by a y. X can be any number, y can be any number other than 0. And finally, our long division symbol, where the numerator is inside of the house. So I'll put an x inside of the house, followed by y knocking on the door. Again, the variable knocking on the door can be any number other than the number 0. And let's go ahead and fill in this symbol with two variables. The leading number is the number that goes in the numerator, and the following is the number that goes in the denominator. So we have our different division symbols. These are also known as dividend symbols, but the number that comes before that division sign, so in this case x, it is known as the dividend, or what we've been calling it is the numerator in some cases. So it can be the dividend or the numerator. The number that follows that dividend symbol or division symbol, in this case y, I'll use this y over here. We've been calling it the denominator, but it's also known as a divisor. So divisor or denominator. Now whenever you divide a dividend by a divisor or a numerator by a denominator, you always get an outcome, which we call the quotient. So Q-U-O-T-I-E-N-T. Let's fix that I real quick. Now the same rules of using positive and negative signs apply to division as they did in multiplication. Let's go ahead and write those out real quick. I'm going to choose that orange pen again. So if I were to take a positive number and divide it by a positive number, I'd get a quotient that is positive. If you take a negative number and divide it by a negative number, you get a quotient that is positive. If you take a positive number and divide it by a negative number, you get a quotient that is negative. And if you take a negative number and divide it by a positive number, you get a number or quotient that is also negative. So this rule still applies when using division. Also, the same rule applies when you're dividing with more than two numbers. So let's look at what 12 divided by 2 is real quick. So we have 12 divided by 2. We know that 12 divided by 2 is equal to 6. And let's look at what if you added another number. And let's look at what happens if you were to divide with more than two numbers. So this time we'll say 12 divided by 2 divided by 3. Well, we're first going to divide 12 by 2. Well, we know that 12 divided by 2 is 6. And from here, you can take 6 and divide it by 3. 6 divided by 3 will give you a value of 2. Cool stuff. Let's go ahead and box this up. So regardless of how many numbers you're dividing by, you divide the first two numbers, and then one at a time, you divide with each subsequent number in the list. One last note here, we can see that 6 is equally divisible by 3. 3 divides into 6 2 times. But what happens if a number is not equally divisible into another number? So let's just look at 17 divided by 2. Well, using long division here, I'm going to take 17 and divide by 2, I know that 2 does not go into 1, but it goes into 17. 8 times 2 is 16. And if I subtract out, well, 17 minus 16 is 1. Well, at this point, I have something known as a remainder. I can see that 2 does not equally divide into 17. So therefore, I could stop here and say I have 8 with a remainder of 1. But typically when you get more advanced, you'll continue on. You'll say, let's not call 1 a remainder. Let's add a decimal after the 17. And if I put a decimal inside of long division, I have to put 1 up top. And now I'm going to drop a 0 down. I'm just adding that additional 0. And I'll put a 0 next to the 1 to create 10. 2 goes into 10. Well, it goes into 10 5 times. So, well, 5 times 2 is 10. So now I'm going to, when I subtract, bottom out at 0. There's no remainder here. My remainders become a decimal. So what we can see here is that remainders can be expressed as fractions, decimals, and even sometimes they'll be expressed as percents. Let's go ahead and just box this last problem up. Cool, guys. That's a lot of information when dealing with operations, and 4 of the basic operations are addition, subtraction, multiplication, division. We also said we'll look at exponents and powers in future videos. See ya.